Hi guys, welcome back to lesson 22 where we're talking about optimization for Calculus BC. And the first two examples we've done what I call classic optimization questions, and we're going to continue with classic optimization questions that you guys usually will see on the BC exam. So question example 3 says find the point on the parabola x equals negative y squared that is closest to the point of 0, negative 3. So if we look at our picture here, we want to know at 0, negative 3. So we're looking at this point right there. And the curve itself is x equals negative y squared. So you guys could rewrite this if you needed to as y squared equals negative x. And so based on your knowledge of parent functions and transformation of parent functions, you know that because it's y squared instead of x squared, it's going to be hugging the x-axis. And the fact that it's negative means it's going to be approaching the left-hand side. So the question is really asking here is what point on this graph is this distance going to be at a minimum, right? So the distance here is going to be a minimum. So the first thing we're going to do here is notice the word I just used here, and this is going to be a distance. So this is going to be what we're trying to find, x comma y, and this is going to be the point 0, negative 3. So what I just said is the equation that we're going to need. We're going to use the distance formula, right? The distance formula. So we're going to go ahead and write that the distance is equal to the square root. And so it's going to be x minus 0 quantity squared plus y minus negative 3 quantity squared. All right, so a couple things we're going to do here for this problem is we're going to go ahead and start simplifying just a little bit just to kind of get this looking a little bit nicer. So this is going to be x squared. And this is going to be equal to plus, and this is going to be y plus 3 squared. Now, one of the things I said in the previous two videos is that we need to make sure that we have an equation, one equation with the same variable. And so if you guys look at this, we have an x and we have a y. Well, we can't do that. We actually have to find a way to substitute one in for the other. Well, beautiful for us, we know what x is. We know x is actually simply equal to negative y squared. Yes, you could also solve for y, but why do that? Why do that when you can easily solve for x? So I can go ahead and write the distance is equal to, and I'm going to replace my x with negative y squared, right, plus y plus 3 squared. Do not FOIL this out. You don't need to do it. It's going to be much easier for you when you're going to do it this way. And then the last thing I'm going to do here is just to simplify a little bit more. And I'm going to get y to the 4th and then plus y plus 3 squared. Now, one thing that you can absolutely always do for this problem is that if I'm optimizing the distance, I can do the same thing with the distance squared. So we actually can save ourselves so much time and so much energy with this derivative. It works out nicely that optimizing the distance and the distance squared is going to give you the same problem. And that's supposed to be a positive y, by the way. It looks like that. So I can go ahead and square the distance. And so when I'm telling you guys for the distance problems, you can already start at d2. So I can optimize my d squared in lieu of my d. So all I have to do is find the derivative of this, which is actually pretty awesome for us to do. So I'm going to take the derivative of my d squared, and that's going to give me 4y cubed plus, using the chain rule here, 2y plus 3 to the first times 1. And now I want to set this equal to 0, right? So once we have ourselves an equation, we want to get our variables in terms of 1. And usually, this is always going to be how you do it. You're going to use this to substitute in. And so we're going to go ahead and find out what our y value is, right? What our y value is. I'm going to go ahead and erase this because we need this a little later on. So we're going to get that 4y cubed plus 2y plus 6 is equal to 0. Now, this question, we're going to pull out a 2. We're going to pull out a 2. And now this question definitely would be more a calculator-based problem to do, but it actually is, believe it or not, a factorable thing. And I don't know who would know this right off the top of their head, but you could absolutely do it. So you would get something, on a calculator or something where you can find out what this is, but it ends up being this. It ends up being this, where this actually ends up factoring to y equals -1, and this does not factor to real numbers. So you're going to get the fact that y is going to end up being -1. So the examples you guys would see in class would most likely be something where this would be easily factorable, where you would have two y values. And the good thing about this, guys, is that let's say you get two y values. Let's say you get the y values of positive and -1. So visually over here, you don't have to do a number line or anything like that for this problem, because you know that you're looking at something in the third quadrant, right? You know that x and y both have to be negative. So if you get y equals -1 and y equals +1, that's obviously going to be, the answer is going to be quadrant 3. Now let's say you get -1 and -2. That's a whole different story. I don't see that ever happening. If you do, you can always go back and do your whole number line thing and just see which one of them actually goes. Because again, we're looking at a minimum here. So which one ever goes from a negative to a plus, and that's going to be your minimum. So that's just a way to do that. But anyways, I'm babbling now, so let me go ahead and just plug in -1 to our problem. So once I get this right here, I get x is equal to -y squared. I was given that. So x is equal to -1 squared. So x is going to be equal to -1. And so our value, our point right here, is going to be -1. So this is the third example now where you've seen where, again, we get an equation, and this question is going to always be the distance formula. It's always going to be the distance formula. And so simplify, again, use what's given to you here to substitute in. If I told you y equals something, then substitute in for y. Combine, simplify, you can square it. Again, that the optimization for the distance and the distance squared are going to be the same value. So we're good with that. And yeah, so we're going to go on into the next video where we do yet again another classic optimization question. So I'll see you guys there.